We have this idea that the machine reads, that it somehow understands the nuance of our questions. But honestly, that's just a comforting illusion. Today, we're going to pull back the curtain and really look at the mathematical and statistical engine that is a large language model.
And really, that's the core truth we have to start with. An LLM isn't a thinking entity. It's a prediction machine. It's been trained on this vast, vast ocean of human text, and its only job is to calculate what comes next. It doesn't know what you mean, it only knows what's most likely to follow. Okay, so let's start peeling back the layers. And the best place to start is with that term we hear all the time, GPT. The name itself is actually a blueprint for how these things work.
Each letter here tells a piece of the story. Generative, pretty straightforward. It can create new stuff. Pre-trained, meaning it's already done its homework by studying a huge library of text. But the real game changer here, the one we really need to focus on, is that T for transformer. To really get what's happening now, we have to rewind the clock to 2017. A single research paper from Google came out, and it introduced the transformer. Before this moment, machines were frankly terrible at understanding context in long sentences. This is the bedrock for pretty much everything we call AI today.
So what was so special about the transformer? Well, it all comes down to this one key idea they introduced, something called the attention mechanism. This is the secret sauce that lets the model figure out which words in a sentence are the most important to pay attention to. Let's see it in action. Think about the word bank. In that first sentence, the attention mechanism sees bank and it also sees climb. It does the math and figures out, hey, these two are statistically related, so it correctly infers a riverbank. In the second one, it correlates bank and deposit and infers a financial institution. Now, this isn't understanding. It's not thinking. It's just incredibly sophisticated pattern matching in a high-dimensional mathematical space. So this brings us to a crucial point. When we see an LLM write a paragraph, it's not being creative like a human. Not at all. It's just executing a surprisingly simple loop over and over and over. It's purely mechanical. The model gets an input, something like, "We finally sat." It crunches the numbers and predicts the most probable next word is down, so it tacks that on. Now the new input is, "We finally sat down," and it does it again and again. Word by word, it just keeps assembling the most statistically likely sentence it can. Okay, but how does a machine actually do any of this? I mean, it can't read words like you and I. It has to convert our language into the only thing it really gets. And that brings us to the most fundamental reality of all this. For a computer, for any LLM, all of our beautiful, complex language has to be boiled down to cold, hard numbers.
And the way they translate our world of words into their world of numbers is through a process called tokenization. It's a two-step dance. First, it breaks our text into smaller chunks called tokens. Then it swaps each of those tokens for a unique number, a token ID, from its own private dictionary. Here's exactly what that looks like. The question, "Who is PM of India?" gets chopped up into those tokens you see. Then each piece gets replaced by its number. That list of integers, that's what the neural network actually sees. And here's something you've got to keep in mind. This isn't a universal language. Each model has its own custom dictionary. So the number that means India to GPT-3 is totally different from the number that means India to GPT-4. Now, why does all this matter? Why do we care about tokens and numbers? Well, because this whole system, it isn't free. It has very real limits, both in terms of what it can do and, frankly, what it costs. The first big limit is something called the context window. You can think of it like the machine's short-term memory. It's the maximum number of tokens, both what you put in and what it gives back, that it can keep track of at one time. If your conversation gets longer than that window, it literally starts to forget the beginning. And then there's the money. Every single one of those tokens has a price tag. And as you can see, companies charge you for the tokens you send in and for the tokens the model generates back to you. This means that longer, more complex conversations aren't just more computationally intensive, they are literally more expensive. So the next time you use one of these systems, just remember what's happening under the hood. The statistical guesswork, the conversion of your words into numbers, and the cost of every single one of those numbers. It really leaves us with a pretty provocative question. In a world where every thought has a price per token, what ideas are simply too expensive to be processed?